So our new stuff for Unit 3, we're going to be looking, at least for tonight, we're going to be looking more at these algebraic numbers. What we've looked at so far is basically one-digit algebraic numbers in our fractions. So we're going to be looking in more detail at multiple-digit numbers. To deal with this, let's review our whole numbers just a little bit. We had our place values, the ones, tens, hundreds, thousands, and so on. But we've looked at powers just enough to know that these are actually powers of 10. Of course, 10 is 10 to the power of 1. 100 is 10 to the power of 2. 1,000 is 10 to the power of 3. 10,000 is 10 to the power of 4. The one that's not as obvious but is just as true, 1 is 10 to the power of 0. Anything to the power of 0 is 1. We've mentioned that once or twice before. Something to make sure we remember. And we can keep going over here. 10 to the power of 5 would be the 100,000s. And so on. Those are our place values. Our numbering system is what we call a decimal or a base 10 number system. It's because our place values are all powers of 10. They're exponents with a base of 10 in the power. In our algebraic number system, it works the same way. We have digits. The only problem is the place values of those digits are not based on tens, they're based on variables. For example, if we're using the variable x, this would be the x to the 0 place. Well, what's x to the 0? 1. It's the ones place. In every number system, that last digit is the ones place. This is x to the power of 1, or just the x's. This is the x squareds, x to the thirds. You might be looking at that thinking that doesn't look really familiar. But it is. You've all seen things like this. 3x squared plus 7x plus 4. That's an algebraic number. Now, unlike our whole numbers, where you just write, you write 5, 2, 8. That is implied to be 5 hundreds, 2 tens, and 8 ones because of their position. Here we always write it out in expanded form. We have to write the 3 and the place value of x squared, the 7 and the place value of x. That last digit, if there's no variable there, it is implied, assumed to be the ones place. And that number works just like any other whole number, anything else that we use, with a couple of small exceptions. One we just mentioned, it's always written in expanded form where we have the place values written out. Second is it's not always, we kind of mix bases a little bit. We could have 5x plus 3y plus 7. To where it's not all place values of x's, we have different variables mixed in together, which confuses a little bit. That breaks down the similarities just a little bit. They're not quite as close together. But anyway, our addition with them is exactly the same. We had 374 plus 213. We line up the columns with the ones under the ones, the tens under the tens, and the hundreds under the hundreds, and we add down those columns. 4 and 3 is 7, 7 and 1 is 8, 3 and 2 is 5. With algebraic numbers, we're going to do the same thing. 2x squared plus 5x plus 7. Now I'm putting this in parentheses, not to tell us to do something here first, but to tell us that that is a single number on its own, that it's separate from the rest of it. Plus, then the second number, 5x squared plus 3x plus 4. So just like we did with our whole numbers, we're going to set this up, lining up the place values. So 2x squared plus 5x plus 7. We're going to put the x squareds under the x squareds, the x's under the x's, and the ones under the ones, and we're adding down the columns. Now here's another one of our differences. When we add, there is no carrying or borrowing. 7 plus 4 is 11. We just leave that as 11 ones. There's no carrying it into the next column or the next place value. 5x plus 3x is 8x, and it's positive, so we're going to put a plus in front of it. And 2x squared plus 5x squared, 7x squared. Just like dealing with whole numbers. Now it's time to point out a third difference between our algebraic numbers and our whole numbers. Actually, our integers, I should say, because we're not going to be talking about just whole numbers right now. For a whole number or an integer, either the whole number is positive or the whole number is negative. If I have negative 375, that is a negative 300s and a negative 7 tens and a negative 5 ones. In an algebraic number, however, each digit can be positive or negative on its own. We can have 5x squared minus 7x plus 2, where the 5x squared and the 2 ones are positive, but then 7x is a negative 7x. So, if we're going to throw that into the mix, we might have 5x squared minus 7x plus 2, we just will use that number again, plus 3x squared plus 9x minus 11. We can have multiple digit numbers in each place value now. And we'll add. We'll set this up. 5x squared minus 7x plus 2. 3x squared plus 9x minus 11. And we are adding down the columns. 2 plus negative 11 is negative 9. Negative 7x plus 9x, positive 2x. We're going to put a plus in front of it. 5x squared plus 3x squared, 8x squared. So we have to deal with the negatives, but still not terrible. So again, this one here, we'll set it up. Negative 7x squared plus 5x minus 15. Now we've talked about this a little bit before. The minus here goes with, that's a negative 7x. The positive goes with the 5, so it's a positive 5x. The minus here goes with the 15, so that's a negative 15. So we're going to line up our other place values here. This is 3x squared, a negative 19x, and a positive 11 ones. And we're adding negative 15 plus 11, negative 4, bless you. 5x plus a negative 19x, negative 14x, and negative 7x squared plus 3x squared, negative 4x squared. There we go. Try this one in your notes. So, you line it up again. 9x squared minus 11x plus 2, negative 6x squared plus 5x minus 8, and we are adding. So 2 plus negative 8 is negative 6. Negative 11x plus 5x, negative 6x. 9x squared plus negative 6x squared, 3x squared. Good. How many of you had that one correct? Good. it can be complicated just a little. Well, first of all, before I go any further, I want to point out, when they're in this form, this is the purest form of an algebraic number where it's a single variable and just its powers. As we pointed out, kind of like our decimal place values with whole numbers and integers. And in this form, each of these terms and each of these digits in an algebraic number are called a term, is called a term. Each of them has a degree. And the degree is the power of the variable, the power of the place value. For example, the 3x squared has a degree of 2. Now, in whole numbers, the same thing applies. We just tend to not discuss it. In 384, the 3 has a degree of 2. Why is that? Because it's in the 10 to the second, 10 squared place value. We're just naming the exponent, the power of its place value. It's a little more obvious with algebraic numbers because the place value is always written out, and it's the power on that variable that defines the place value of the digit. Just like with whole numbers, algebraic numbers are almost always written in what we call descending order. Whole numbers and integers are always written in descending order because the place values tell us what that digit means. 384 has a very different meaning from 438 because the location of the digit defines its value. Well, even though we always write out the place values in algebraic numbers, we still try to write them in descending order. For example, 7x plus 3x squared minus 2 is not how we would write that number. To be more grammatically correct, we've brought up math grammar a few times, we would write this with the highest power first. So 3x squared plus 7x minus 2 would be in descending order, going from the highest power of our variable down to the lowest power, which is x to the 0, or the ones place. So in your notes, quickly, put that in descending order. So, what goes first? Negative 9x to the fourth. Good. What's next? Plus 7x to the third. Good. There's no sign in front of it, but it's positive, so we put a plus there. Next, plus 14x squared, and then minus 8x and plus 7. There we go. Any questions? Okay. Again, that's standard with any whole number or integer. We just take it for granted that they're always in that order. If we had like 384, if we're writing that in expanded form, there's no reason why we have to do it in descending order. We could write that as 8 tens and 3 hundreds and 4 ones. That has the exact same meaning as having the 300s first. It's just we're so used to seeing it put in that order with the largest place value first, or the highest powered place value first. That probably seems a little awkward to look at. So anyway, we've been adding these algebraic numbers. The technical term is polynomials. Poly just means multiple digit or multiple term. Multiple nomial actually means name. It has multiple names. Each digit, remember, has its own name and a number. So, one last little stab at this here. Probably should have left a little more room than that. Hopefully in your notes you're not in trouble. So let's have you add that one quick and see where you come out. And then we'll move on. So I've got it lined up already. -9 and -13 make -22. 15x from 4x. Positive 19x. -7x squared and 9x squared. Positive 2x squared. And 3x to the third and -8x to the third. Perfect. -5x to the third. So we've got the addition down. We can have as many digits as we want. What's different here?
3x squared, or 7x to the third.
Yep. Okay. We have an x to the third here, but not over here. And there's an x squared here, but not over here. There's missing digits here. Just like if we had 704 for a whole number. When we write that in expanded form, we would write 700s and 4 ones. We wouldn't bother writing 0 tens in there because it doesn't add any value to it. We only put the 0 here because it has to fill that place so that the place values are in the right spot. So we can abbreviate. Zeros are really only there to abbreviate the number. 0 is actually a relatively new concept. It's only been around for a couple thousand years. That's one of the big benchmarks in mathematics. I believe it was the Sumerians that developed the concept of 0. But anyway, so the same with these numbers here. We don't put the zeros in there, but it really is. This number here is really 7x to the third plus 0x squared minus 5x plus 3.
X squared or x to the third?
Well, it's the x squared that's missing.
Oh.
So it's the 0x squared. That x squared digit is not there, so we can put in a 0x squared. Just like here, 7 hundreds and 4 ones becomes 704. The 0 is filling in the tens because there's the tens digits missing. This one then becomes, well, 8x squared plus 2x minus 7. We could put in a 0x to the third up here, but we really don't have to. So now, 3 plus negative 7 is a negative 4. Negative 5x plus 2x is a negative 3x. 0x squared plus 8x squared is a positive 8x squared. And then 7x to the third doesn't have anything to combine with. So there it is. Not so terrible. That part might be a touch confusing, but we can survive it. Subtraction is where things get a little bit uglier. Let's review just a little bit. I know everybody knows this one. 8 minus 5 is 3. But what about negative 8 minus 5? That's negative 8 plus a negative 5. Remember, subtraction always gets changed to plus the opposite. So minus a positive 5 becomes plus a negative 5. And yeah, we have negative 8, negative 5. That is a negative 13. How about negative 7 minus 6? Well, oh, negative 7 minus 9. Well, that's going to become negative 7 plus a negative 9, which is negative 7, negative 9 is a negative 16. Eight minus a negative 4. This becomes 8 plus a positive 4. Remember, the subtraction means we're going to add the opposite. So we're going to add the opposite of negative 4 is positive 4, so that is just 12. It's all looking familiar, hopefully. Maybe not the most pleasant of memories from the last 7 weeks, but still familiar. Or a negative 9 minus a negative 13 is going to become negative 9 plus 13. So negative 9, positive 13 is 4. Negative 7 minus a negative 5 will become a negative 7 plus positive 5. So negative 7, positive 5 is negative 2. Okay, there's a reason why we went over that, because that is the most common source of difficulty when we start subtracting with our algebraic numbers, with our polynomials. Let's have 3x squared minus 9x plus 2 minus 7x squared plus 4x minus 9. Now again, we're going to line up the columns. Now, though, we are subtracting down each column. What is 2 subtract a negative 9? This is 2 minus a negative 9 is going to be positive 11. Good. Negative 9 minus 4. Negative 9 minus 4 will be a negative 9 plus a negative 4, or negative 13x. 3x squared minus 7, x squared. 3 minus 7 is negative 4x squared. What you think? Not pretty, but not horrible. Pretty much. 5x squared plus 19x minus 7 minus 4x squared minus 13x minus 11. So we're going to set this up again. Keeping our columns lined up once again, subtracting down the columns. So again, at this point now, it's just a matter of remembering how to work with the negatives, with the integers. Negative 7 minus a negative 11. Positive 4. Very good. 19x minus a negative 13x. Positive 32x. Very good. 5x squared minus 4x squared. 1x squared or just x squared. We don't need the 1. Your textbook shows you a shortcut to this. What your textbook does is just this. It says take this negative, and since subtracting is adding the opposite, you change this to plus, and then you change the sign of everything in this number. So this becomes a negative 4x squared, this becomes a positive 13x, and this becomes a positive 11. And then you go ahead and add them. Only the part that comes after the subtraction. Just like if you had 8 minus 5, you change the sign of this number after subtraction, it becomes plus a negative 5. Same thing here. Whatever we're subtracting is what gets changed. If that works better for you, that's fine. I prefer to just line them up and treat them like any other number. One for you to try. (5x squared minus 9x minus 15 minus negative 3x squared plus 11x minus 7. Subtract those. Let's see how you do in your notes. We'll set it up again. 5x squared, negative 9x, negative 15, negative 3x squared plus 11x and minus 7. Subtracting down the columns. Negative 15 minus negative 7. Negative 8. Very good. Negative 9x squared minus 11x squared. Negative 20x. And 5x squared minus a negative 3x squared. 8x squared. Very good. Well then, let's make it more difficult. Hey, you've been paying attention. I always make it worse. It's what I do. Part of the job description. So here, again, what do we see that's a little off? A little different.
We don't have an x. Yeah, that one.
Yeah, we have x thirds and x squareds, but not in both sides. So again, when we rewrite this, this has to be written 7x to the third plus 0x squared minus 15x plus 3. This is going to be the 5x squared goes under the 0x squared, positive 9x and a negative 13. And we're going to subtract. Three minus a negative 13 is 16. Negative 15x minus 9x is negative 24x. 0x squared minus 5x squared. Negative 5x squared, and 7x to the third minus nothing is 7x to the third. How would this change if we had this? Go up a little bit, like that. How would this change? I'm going to have you mill that over for just a second.
You don't have the x cubed of x squared.
So the first number is just 3x squared plus 9x minus 13. When we go to do the second number, the 5x to the third is going to go over here. There is no x squared, so I'm going to put in a 0x squared minus the 12x and the positive 7. And we're subtracting. So now I have to come back and put in a 0x to the third up top. I didn't necessarily know for sure that I needed this until I wrote the second number. So I can always insert it in there later. And now we are just subtracting. Negative 13 minus 7 is negative 20. Very good. 9x minus negative 12x is positive 21x. Very good. 3x squared minus 0x squared. 3x squared. And 0x to the third minus 5x to the third. Negative 5x to the third. Any questions? Okay, well, let's have you try this one then. Come on. Try that one in your notes quick. So when we start writing out this first one here, we got the negative 3x to the third. We notice there is no x squared, so I'm going to put in plus a 0x squared minus 17x plus 5. So the second one here, we've got 4x to the fourth. That's got to go up front here. There is no x to the third, so I'm just going to put a 0x to the third under there. Minus 2x squared plus 9x, and there is no 1s there, so I'm just going to put a 0. And we are still subtracting down the columns. 5 minus 0, that's 5. Negative 17x minus 9x. Negative 26x. 0x squared minus a negative 2x squared. Positive 2x squared. Good. Negative 3x to the third minus 0x to the third. Negative 3x to the third. And now we have to put in a 0x to the fourth up here because there wasn't one. 0 minus 4 is negative 4x to the fourth. Any questions? we might run into some things similar to that look like this. Now this is kind of an extreme example, but we will see some in the homework that are similar to this. We do operations with numbers 2 at a time. If they're all the same operation, we can do them all together. But just like if we had 8 minus 3 plus 4, we would go left to right. We would do the 8 minus 3 first, and then add 4 to it. Same here. We're going to do the subtraction first. So I'm going to write that out, 5x squared. Now there is no x, so I'm going to put in a plus 0x and minus 7. 3x squared minus 9x plus 2. And remember, we are subtracting. Negative 7 minus 2. It's negative 9. 0x minus a negative 9x. Positive 9x. And 5x squared minus 3x squared. 2x squared. Are we done? No, we still have plus an 8x over here. Well, that's going to just go with the 9x. So we still got the negative 9. 8x and 9x and positive 8x is positive 17x and 2x squared. What do you think? Are you having fun yet? No? Try this one in your notes quick. So our first step here, we're going to add the 5x squared plus 17x, and I put a plus 0 on here to fill in that 1's place. That's not going to add, we're going to subtract. We're going to subtract from that the 8x squared plus 15x minus 11. So 0 minus negative 11 is positive 11. 17x minus 15x is a positive 2x. 5x squared minus 8x squared is a negative 3x squared. Now what?
Now we're
Add
going to
add 3x squared, which is 0x squared. So we have 2x plus 11. With that, it is time to take a break. It's 4:23, so we'll start lecturing again at 4:33.